Hello and greetings to all watching this. Today, myself, Anton Himmel, and my mate Kevin will be traversing through the topic cache coherence problem and its solution. So, before getting to the topic, let us know what's cache first of all. So, as the definition is given, a cache is a temporary storage area that keeps copies of frequently accessed data or files. It helps speed up access to this information, so when you need it again, your device can retrieve it more quickly instead of looking for it from the original source. So, this means that cache is similar to a RAM, but it is stored along with the CPU, which makes it easier for accessing of frequently accessed data. For example, we know the value of pi is 3.14, and whenever we come across a word known as pi in maths, we need not go and search in some books. We have it pre-registered in our brain. So similar to that, whenever you come across some word which we frequently use it and we have to access it immediately, those kind of values are stored in cache. So you might get a question: what is the difference between cache and a RAM? Cache is smaller, faster, and it is located near the CPU. And as I said, it is used for data which are frequently accessed. Whereas RAM is larger than cache, but still it is faster, not much slower. And it stores programs that are currently in use. And if any other data that has to be taken, it retrieves those from the main memory. So this is how a cache looks like, and this is how an RAM looks like in the modern computers. So what is cache coherence? Cache coherence refers to the consistency of data stored in multiple caches within a computer system. When multiple processors or cores have their own caches, they might store copies of the same data. So this indicates that cache coherence helps us to store data in different caches without having any variations from one thing to another cache. For example, these kind of that's an important note which I forgot. These type of cache coherence occurs in only multiprocessor computers. So multiprocessor computers, each processor has an individual cache, as I said earlier. So each cache stores the data, retrieves the data from main memory or RAM and uses it. So while using it, that each processor might use it for different purposes. So if one processor is using it for a certain purpose, it can change the value, and other changes the value. So instead of making it a hectic schedule, they help it have a same data value throughout the system. And cache core ensures that when one cache is updated, all other caches reflect that change, as I said now, preventing different parts of the system from using outdated or conflicting information. This is important for maintaining accurate and reliable performance in multi-core or multi-process system. So that's what it is. Whenever you want to have the data which should not clash against each other, resulting in a deadlock, we need to ensure that cache coherence works properly. So what's the problem that might occur in cache coherence? Since we have private caches, we don't know how to keep the data consistent across all the caches of individual processors. So in order to find a solution for this, we have few methods. So let us get on to the problem first. So consider this is your multiple processor P1, P2, P3, and P4, and these boxes underneath it are their personal caches. And this is the main memory from where we retrieve our data. And these processor unit and the memory are connected through a common bus. So initially, processor one needs the data, it needs to access A, and it increments changes the value of A to 8 as shown over here. Then processor P2 gets the value of A and adds 2 to it and changes it to 9. So similarly, processor 3 gets the data and subtracts 1 from it and changes to 6. And processor 4 gets value of A and subtracts by 2, and we get the final processor private caches units as these. So whenever we come across the solution, as we saw in cache coherence definition, we need a cache. As per the definition, all the caches must have same values, but here it is different. So in order to find a solution for this, we have few methods which will be discussed by Kevin.
We'll discuss about the solutions for cache coherence. So what it is, we should make sure that the data stays consistent with the data and cache memory and the main memory. So the basic protocol is invalidation-based protocol with snooping. What it does is it searches for the invalidated data and makes sure it stays consistent with the main memory, either by changing it or by doing other operations on it. So let us consider this example. Consider this as a multi-core processor with 4 cores, and each core has its own cache memory and a main memory which is separate. So the main memory has a variable x which has the data 15213. Core 1 and 2 reads the data 15213. So both has the same value over here. And here core 1 changes the value to 21660. Here what happens is the value in core 1 cache is changed as well as in the main memory, but the value in core 2 cache remains the old value. So what it should do is it should invalidate that value and then change it. And there are two methods to change it. One method is the core 2 could read the data again from the main memory and change the value in its cache memory. Or the other method is it could change by broadcasting the value in the cache memory of core 1 to the cache memory of core 2. This is another method to change its value. So the next protocol we're going to see is MESI protocol. MESI stands for Modified Exclusive Shared and Invalid. This is also used to solve the cache coherence problem. So to explain what MESI is, so this is a cache memory and it has a lot of segments in it. And each segment will be labeled as either modified, shared, invalid, exclusive, owned, or forward. So what modified stands for is the data is first read from the main memory and then it will be modified in the cache memory. but it will be different from the main memory, and the cache memory data will be different. In exclusive, the main memory data and the cache memory data will be the same, but uh, the data will not be in any other cache memories of any other cores. In shared memory, it will be like the data will be same in the main memory and the cache memory, but the data will be present in many core cache memories. And invalid is when the data is inconsistent with the main memory and the cache memory. So how it works now? Basically, there are two operations: reading and writing. So what we have to see is when reading, if the cache line is in invalid state, the cache must fetch the data from the main memory or another cache. After reading, it must be set to either shared or exclusive. And while writing, we have to check if it's in a modified or exclusive state. If another cache holds a copy, it must first be invalidated so that the data will not be inconsistent. So these are another set of operations: read it, read miss, write it, and write miss, which will be performed on this cache memory, this in a more MESI. So here we can see that invalid, shared, modified, and exclusive, and the various operations which will be performed on these. So yeah, we can see that, and here I will conclude with this solution. Thank you.